Okay, great. Yes, I see wise. Da, 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 da. Okay, I think we can start. The plan is to ensure that we don't exceed 1 hour. All right, so good morning again, guys. Good to see every one of us. Kind of missed us. I think the last session we held was sometime in April or May this year. It's been a very tough and busy year, but I'm glad we're able to do this month. It's a power-packed morning, and we are discussing cloud misconfigurations. Like we had said in the ad for the session, the cloud has become a backbone of modern IT, right? Particularly for institutions that are big on trying to drive operational efficiency and scaling their business operations. But again, the speed and the flexibility that the cloud offers also come with heavy risks, right? Risks that need to be managed. And misconfiguration is one of the key culprits for any of us that is involved in security assessments of cloud infrastructure. I'm sure you would appreciate what I'm talking about. Most of the cloud breaches, they don't typically start with the hackers. They start with everyday errors, right? One S3 bucket or storage bucket that was not left open to the internet, a security group that was exposed to the internet, a user that has been granted overly permissive access to cloud resources. All this stuff constitutes some of the challenges that we face in the cloud. Taking us through this session this morning is a mentee of mine. His name is Chinonso, a chartered accountant turned into a cloud security engineer. He leads the emerging technology assurance function in one of the tier 1 banks in Nigeria. He is a CISA, a CCSE, among other certifications that he possesses. I call him our industry's finest. If you're new to cloud, don't let some of the technical jargon that will be used this morning phase you. I'm positive that if you pay attention, you will pick up some valuable insights from the conversation. So I'll hand over to Nonso. We will run for 45 minutes or 40 minutes. We will require some ample time to take questions, and then I'll be back to wrap up this session. All right, so Nonso, over to you.
Okay, good morning. Can you please confirm I'm audible? Can I get the Y if I'm
You are
audible?
loud and clear.
All right. Good morning, everyone. Like I've been introduced, thank you, Bostoni. My name is Nonso, and I am a certified cloud security engineer, amongst other certifications. Please confirm you can see my screen.
It's coming up.
Okay. Let me know when it's up.
Yes, your screen is up.
Okay. So good morning, everyone, once again. Thank you for joining this session. Like the host said, we're going to be running through cloud misconfiguration, the small mistakes and the big risk, right? I'll try as much as possible to limit the use of technical jargons relating to the various cloud service provider. I'll also try as much as possible to define some of the concepts or some of the terms that I'll be using for ease of clarity while the session is ongoing. So today we're going through a brief introduction around cloud computing, the various cloud computing services, the deployment models, concept of shared responsibility model, of course, the configuration, real life exploits of some of these misconfigurations rather, and way to mitigate these misconfigurations. I'll also be doing some demonstration, which is purely for learning purposes. Okay, moving on. What is cloud computing? Just a brief introduction. So when we talk about cloud, we don't mean something floating in the sky, right? We mean your ability to access a remote server that is housed in someone's data center. And your access to these remote servers is through the internet, right? It's through the internet. If Sorry. Okay. So in cloud computing, one thing that always governs us is a pay-per-use pricing. So if I go on Azure, for instance, and say I want to spin up a virtual machine and I want to spin up an S3 bucket, right? The virtual machine, as long as it's running and as long as traffic is coming to that virtual machine, you're going to be charged. So it's a pay-per-use pricing model that is verily used in cloud computing. So when we say cloud, you're somewhere, you're accessing a server. Think of it like a rent instead of owning, right? Instead of going to build a house, you just rent the house, take a 1, 2 bedroom flat, and pay your annual rent for staying in that particular house, right? So moving on, what are the various or major cloud computing services? We have majorly three cloud computing services. You have the IaaS, you have the PaaS, and you have the SaaS. So IaaS stands for infrastructure as a service. PaaS stands for platform as a service, and SaaS stands for software as a service. Now, if you look at the diagram I have on my screen, you will see to the right something that speaks on control, right? In infrastructure as a service, you have more control. And as you go up this pyramid, you have less of control. So there's an analogy I like to use when explaining this. So let's say you want to establish a restaurant, right? In infrastructure as a service, what we're saying is if you want to set up the restaurant, you go to the market, you get your kitchen utensils, you get your oven, you get your fridge, you rent the place you want to use for the restaurant, you go back, you put your fridge, you put your oven, you get it fixed up. You are entirely responsible for the kitchen, the cooking, the setup, the cleaning. That is infrastructure as a service, right? So tying it to the cloud environment, what we're saying is when you spin up things like virtual machine, when I say virtual machine, I mean servers. When I say bucket, I mean storage. So when you spin up things like a virtual machine, right, you're responsible for the installation of, let's say, an antivirus on that virtual machine. When you spin up a storage, you're responsible for the configuration of that storage. That is basically infrastructure as a service, right? You have access to things like computing, storage, networking, right? Infrastructure as a service, you have more control. If you move up the pyramid to platform as a service, still using as an example of a restaurant. So let's say you then get a partly furnished restaurant, right? The restaurant already has its oven, everything is set. You just come with your recipe and start cooking. That is platform as a service. Now, tying it to the cloud environment, what we're saying is your cloud service provider, that's the people offering you the service, they're going to be responsible for the operating system, the runtime. You just come with your application or your codes and just deploy and run, right? That's platform as a service. And you have, if you're looking at Azure, you have things like your Azure App Service, you have things like the Azure SQL database, right? It's a managed database, it's a form of platform as a service. Now, moving up the last point of the pyramid, which is software as a service. This is going back to our restaurant, right? our restaurant illustration. What we're saying is instead of setting up a restaurant, going through all this stress, why don't I just order food from Child Deck? They cook it, they do everything, and bring it for me. I just pay the fee, right? So that's software as a service. You're consuming a finished product, either via your web browser or a dedicated desktop client, you know. And most of the CSPs that offer, as cloud service providers that offer this, they offer it based on a monthly or annual subscription fee, right? So moving on, there's no way we'll talk about cloud without talking about the concept of the shared responsibility model. It's a framework that governs how responsibility is shared between in the cloud, rather. Um, there's something AWS puts out. There's a concept they put out, which is called security of the cloud and security in the cloud, right? Please confirm if I'm still audible.
Yes, yes, we can hear you.
Okay. All right. All right. Okay. So there's something called security of the cloud and security in the cloud. Now, security of the cloud is basically just securing the infrastructure, right? The cloud service provider are the ones responsible for security of the cloud, while you, the consumer, is responsible for security in the cloud. Right. Now, the shared responsibility model also hinges on the various cloud compute models we have, right? We have the IaaS, like I said, we have the PaaS, and we have the SaaS. Now, looking at your screen is a generic representation of the shared responsibility model. Right? My advice is always, if you want to engage an Oracle cloud service provider, for instance, to be nice to see the shared responsibility model of Oracle, to see some of the services they're going to be responsible for, right? If it's for AWS, the same thing. If it's for Azure, the same thing. But this just gives us a generic idea, right, of what or who is responsible for what when it comes to cloud, or when it comes to cloud computing. Now, when it comes to on-prem, you see it's labeled or red, right? So from the physical data center up to the information and data stack you have on the screen, everything, since you have the servers in your premises, you control it. You control the data center up to the information and data. Right. Now, for infrastructure as a service, which we had explained earlier, that you have more control, right? In terms of the physical data center, physical network, and physical host, it is controlled by the cloud service provider, right? They are the one that manages the data center. They ensure that the network is fine at the DC. Physical hosts that are going to be hosting your guest operating system is managed by them. Now, if you look at the operating system up the stack to information and data, rather, you will see that that is now your responsibility, right? Now, if you go to platform as a service, you'll see that the operating system is purely managed by the CSP. Like I said earlier in my instance, the operating system, the runtime is all managed by the CSP. You just come with your applications, put it, and you run. For software as a service, the cloud service provider has already finished the application. It's a finished application you're getting, right? The infrastructure part of the identity and directory is handled by them, while the aspect of configuring access, the little bit tweak on your software as a service is done by you. Your accounts and identity, profiling users is done by you. Devices that can access the software as a service is enabled or disabled by you. And your information and data rests with you, right? Now, understanding the shared responsibility model is crucial in understanding who is responsible for what in terms of security, right? I cannot say, for instance, I'm consuming an IaaS service. I cannot say, oh, I'm in charge of securing the physical data center. It's not within my purview. It's the CSP's bit because it is within his purview. That's why it's important. It's crucial. We speak on the shared responsibility model. So you know where your do's and don'ts lie. within the cloud environment. Now, moving on, we have what we call cloud misconfigurations, which is why we're here. What are they? Errors, gaps, oversights, that unintentionally exposes systems, data, or services to security risk. Now, they can occur across environments, IaaS, PaaS, SaaS, they can occur, right? But for sake of this presentation and for sake of time, we're going to be specific to infrastructure as a service because, like we said, you have more controls, so you have more duties in an infrastructure as a service kind of cloud service. So most times, why do these misconfigurations occur, right? They occur as a result of understanding of the security controls. When I get consulted and I go to institutions, um, you see that some of the administrators charged with managing the cloud environment do not have the sufficient knowledge of the cloud security in that environment. Disabled or misconfigured login, some of the things that happen. So you have an issue that comes up in the cloud environment, and we want to be able to look at logs to be able to point out who conducted or who did a particular task, right? But because the login was not enabled, you can't see such. A case in sight was when my past life, when I had to do consulting for one organization, right? They had an AWS environment, fine, right? They had the resources running. And if you're familiar with the AWS environment, there's something we call CloudTrail. Now, what CloudTrail does is it records every API call, right? Every activity that is performed within your AWS tenancy. It does that, right? However, the default CloudTrail that comes with AWS will just record some of the events that happen. It does not record activities conducted within a resource. Example, you have an S3 bucket, which I said is a storage. So think of it as a storage. It's a storage where you can store text, images, files, any kind of data, right? Now you have that, right? They expected, or what they thought was, oh, since CloudTrail is already there, it was going to record whatsoever anybody does on the S3 bucket. But that wasn't so. You were supposed to set up a CloudTrail in AWS. And as part of your configuration, there's something we call data events in AWS. You were supposed to configure that and list the kind of activities you want to be logged for your S3 buckets or for your storage, right? That wasn't done. And as such, it was difficult to find out who did what on that particular S3 bucket, right? You have over-reliance on default settings. Some of these cloud environments, they call default settings. We're going to be seeing some of this as the slides progresses. You have shadow IT or carelessness from administrators. You have instances where some administrators they just spin up servers, assign them public IP, open them on port 22 to anybody on the internet. These are risk, right? So moving on, there are various cloud configurations. Please, are we still together? Can I get a why if we're still together? So I know that I'm not speaking to myself.
Yeah, we are still together.
All right, thank you. So you have common cloud misconfigurations. Now there are various kind of cloud misconfigurations, but what are the common cloud misconfigurations we see, right? Based on experience, based on jobs we have to do for other institutions, what are the common cloud misconfigurations we see? So first on the list is overly permissive IAM roles, policies, and weak IAM structure. Now, I'm going to be showing slides of what some of these misconfigurations are, but let me just speak briefly to each of them. For overly permissive IAM rules, what we're saying is we've seen instances where someone who is supposed to function as, say, just if let's say you have Mr. John. Okay, let me use an example. You have Mr. John within your environment. Now, Mr. John is supposed to be a security person, right? Now, because the person administering the cloud environment doesn't have sufficient knowledge of the rules, right? So what you see is that they give John administrator access, right? And sometimes this administrator access that is given to John, they attach it to him directly, which becomes an issue, especially in large institutions. You have an institution where you have 200, 300 people that have access to your AWS environments, and you are attaching permissions directly to those people. It becomes difficult to track, right? The best bet, create a group, attach the permission to the group, put those people or those personnel in that group so that they can inherit the permission. That way, it is easy to remove someone from, you remove someone from administrator group. You know, he no longer has the permission, right? You put the person in maybe a security reader or a global reader group. That is fine. But when you keep attaching that permission directly to the person, it becomes a bit of a tussle to manage, right? And as such, you see people having permissions that they ought not to have, right? We've seen instances of service accounts. You have service accounts that can perform interactive logon. You know, they have access to the console. You create a service account on AWS, console access is enabled. Why? You know, so there are various issues under over-permissive IAM rules or policies, which we are going to see as the slide progresses. You also have instances of publicly exposed storage. Oh, there are lots of stories concerning publicly exposed storage, whether it's your S3 bucket in AWS, whether it's your Azure Blob, whether it's your Google Cloud storage, or even your storage in Oracle Cloud, right? Yeah, always. And so I think most of the exploits I've come across, right, revolves around this publicly exposed storage. You also have misconfigured security groups. Very, very, very important. Security group firewall rules. You see instances of security groups that are configured. So security groups they're like rules that protect your resource, right? They detect what kind of rules are allowable to your resource, be it your virtual machine, your servers, or your storage, right? So you see instances of virtual machines. If you look at the security group, port 22 open, source IP, any, destination IP, any, and such resource has a public IP. It becomes easy for Mr. A or Mr. B to try and SSH into your server from the comfort of his house, right? Something we need to look out for. Firewall rules. You see firewalls that are without any form of filtering. They just set up the firewall and leave it. There's no even there's no traffic configured to route traffic from the resource or to force tunnel traffic from the resource to the firewall for inspection before hitting the resource. You have disabled or insufficient logging or monitoring. I've hammered on this. You have non-rotation of access keys or secrets. You have exposed access keys or hard-coded secrets. And you have over-reliance on default settings. These are some of the common cloud misconfigurations we see in today's environment. Okay, so now moving on, right? This is just a brief example of overly permissive rules or policies and weak IAM, right? Now, in 2017, Deloitte was attacked, right? Deloitte, they were hit by a cyber attack that revealed certain client secret emails. What was it? A privileged administrator's account lacked multi-factor authentication. That was the sole root cause. Now, from the source, the lack of a security, a second verification layer rather, right, allow the attacker to, through guessing, break in, access sensitive information, including emails and client data that you had up there in Microsoft's Azure cloud service. Now, if you look at this issue also points out, I don't think I said it during IAM, You also have instances of absence of multi-factor authentication, right, on the cloud environment. It is very important, especially for normal users, right? Multi-factor authentication is a second level of layer that should be replicated in the cloud environment. Over time, what we've seen is um, the care given to on-premise, right? The care given to your infrastructure you have on-premise is somewhat different from the care that is given to your cloud environment. That's what we notice sometimes, right? So you have on your on-premise environment, you have multi-factor authentication, good and fine. You have all those, but in the cloud environments, you don't have that. Sometimes you don't have that enabled, right? Now, this is a case study of real life hits that revealed certain information of clients as a result of absence of multi-factor authentication. Now, if you look through, I have a screenshot here from an account on AWS. Now, the account is titled Antivirus Service Account, right? You will see that from the naming of this particular account, one can tell that, oh, this is a service account, right? There is something it is doing. Maybe it's being integrated with to ensure maybe EDR logs are being piped or something, right? But there's a service that this particular account is holding, which you ought to understand, right? As a part of security assessors, as part of security-driven individuals, right? Now, but what we can tell from these screenshots is that you have an antivirus service account that has a console access enabled. Why? Right? Why do you have a console access enabled for a service account that has no business with a console? You also have an antivirus service account that was attached an administrator access. So you see, you have a service account is enabled without an MFA. Console access was enabled without an MFA. And you have administrator access assigned to a service account. Why should a service account have an administrator access? It gives it permission to a whole lot of things it can do and undo within the AWS tenancy of the environment, right? Because of time. Moving on, you have another user called Olabody. Now, this is a standard user, this is a normal user, right? And what we're trying to see here is you're seeing Olabody was assigned administrator access, no problem, but this permission was attached directly to Olabody. Still pointing to that instance we said of assigning permissions directly to users, right? You should group, you have a group, assign the permissions to the group, right? Put Olabody as member of the group. Olabody tends to inherit the administrator access instead of attaching directly. It becomes an issue when Olabody moves. He moves to, let's say, a role that doesn't require him to have certain elevated privileges, right? At that point, because these things are attached via directly, right, it becomes an issue. You might not know the person assigning these roles, right, might not know that there was a permission assigned to him directly. He might just go to body, add permissions, or move body to a new group. Let's say they switched processes, right? And they started doing group addition. We also see that. So some organizations they start off with attaching permission directly, but they've gotten the advice, okay, fine. There was no cleanup done. They just started creating group and started moving people to the group. The permission was assigned to that individual himself, right? So the individual still retains that role, even if he's moved to a group, right? So cleanup should be done post the startup of the group permission thing within the environment. Moving on, you have so this I put this here so that if you're using AWS within your environment, you can appreciate credential reports, right? Now, what this does is it gives you an overview of all the users in your account, what has been happening. In AWS rather, you have root account. Root account comes with the AWS, and it is always advisable you don't use your root account for daily activities, right? It is always advisable from AWS white paper that you should not even assign access keys to your root account, right? Your root account should have multi-factor authentication enabled, right? Now, this credential report, what it does is when you spool it, and you download it, what it does is it gives you an overview of what's happening in terms of users in your environment. You will see if someone is using the root account to perform daily activities. You would see their aside from your cloud trail. You also see it in the credential report. You see when last people rotated their access keys, which is very important. You see when last people rotated access keys. You will see people without MFA. It's a report that gives you a whole lot of information if you're able to review. So if you have an AWS or if your institution, is using an AWS environment, you can afford to download these credential reports. You can also set up AWS, they have free services. You can set up free services, play around these things, download credential report, look at the kind of information it is giving to you, right? As security-driven and inclined personnel, you will now be able to understand or appreciate, oh, okay, credential reporting is very, very, very important. In terms of default settings, right? In terms of distances, this is just one of in an AWS environment, you can see from the screenshot that this AWS account is using the following default password policy. You see the default password minimum length to be 8 characters, and other kind of attributes there. Now, organizations tend to have a policy on password, right? Now, it would be nice to actually ensure that some of these default settings are aligned with what your organization has set up, right? The defense layer concept involves setting multiple layers of defense such that if one is breached, the other can act as a compensating control. While there are no silver bullets to all this, right? Our aim is to try and make it as difficult as possible, right? This involves looking at some of the things like default settings, IAM policies, and all these items that has been spoken about. So if you go on Azure, for instance, this is AWS. If you go on Azure, for instance, there's something called Entra ID on Azure. Go around the security settings, you will see some default settings that ought to have been toggled off, right? So some of these default settings, right, I think we should look out for. If you get CIS benchmark, one of the standards concerning some of the cloud computing environments, they also speak to some of the default settings that are supposed to be toggled off or toggled on, right? Are we still together? Please confirm I'm still audible and we are together.
Yeah, audible.
Yes. Yeah.
All right. All right. Thank you. Thank you. Thank you. Okay. Now down to misconfigured security groups slash firewalls. Right. Now what happened? Capital One was hit. 100 million Capital One credit card applications and accounts were stolen. What happened? Right. Now, if you look at the story, there was a former AWS employee, that's from the reports, a former AWS employee called Paige Thompson, right? He discovered a vulnerability with the WAF that was protecting some AWS resources of Capital One, right? It's a layer 7 control. So she was able to trick, now due to a configuration error, she was able to trick the WAF, right? Which allows SSRF, that server-side request forgery attack, right? So she tricked the server into executing commands on behalf of her, right? So what that happens is, let me explain. In AWS, there's something called IAM rules, right? Now, I'm trying to paint an example. You have an EC2 instance, which is called a server, right? Elastic Compute 2, which is called a server, right? Now, in your environment, let's say you have a server that is supposed to talk to an S3 bucket, right? Now, the S3 bucket, let's say the EC2 instance was maybe expected to get information from the S3 bucket or supposed to put some information in the S3 bucket, right? But let's just establish the fact that a server was supposed to communicate with a storage account, right? Now what happened? If you use IAM role, right, service accounts, instead of using service pure access keys or hard coding some of those keys in the code, right? AWS will tell you, assign an IAM role to your server, right? Now, the IAM role you're assigning to your server has a permission that comes with it. So let's say it's supposed to get data from a storage called non-source storage, right? Now, I now assign a permission to the IAM role, get so, or get from S3 or get from non-source buckets, right? Now, when you assign that permission to the IAM role, you assign that role that you've given this permission to the EC2 instance. Now, what that happens is whenever the server is trying to communicate with the storage, there is a request made to the EC2 instance metadata service, right? Which then in turn gives it a temporary credential, right? Now, that credential is what is used to access the S3 bucket. Now, one sweet thing about this is the credential rotates, right? It rotates, so it's not fixed. Unlike you had coding access keys or something in your code, right? Now this one rotates. Now, because of this vulnerability, what Paige or what Thompson did was she was able to trick that into requesting the credentials from the EC2 instance metadata service, right? Now, when she got that credential had broad permissions, right? Broad permissions. So some reports said there was a wildcard attached to the S3 permission, meaning that she could access all the S3 buckets, right? And that was why she was able to download as much as 30 gigabytes of data across, some say 500 buckets, some reports say 600 buckets, some reports say 700 buckets. She was able to download that. And as a matter of fact, she kept bragging about it, even in there's their communication. She bragged about it on GitHub. She bragged about it on one of their Slack channels, you know. Fortunately for her, she was picked up and the story continues. So because of time, we also had issue of Tesla, right? Due to network misconfiguration. What happened? There was an admin console, right, that was exposed to the internet. And not only was it exposed, it was not password protected, right? So hackers were able to get in. That was what Red Locker reported, that hackers were able to get in and they set up a crypto mining software within Tesla's environment. They call it Stratum, right? So they use it to mine cryptocurrency. So they took advantage of the cloud compute power of Tesla and was able to set up, a crypto currency mining software. This is as a result of poor configuration, right? So just to show us what it looks like, this is what it looks like, right? This is from Azure, right? And if you look at this security group, you will see that there's a network interface card public IP that is attached to the virtual machine, right? Which is the server. There's a public IP, and there is the inbound rule. What has been allowed? What has been allowed? So you look at the rules, you see SSH has been allowed on port 22, source, any, and also can afford to hit it from a simple putty on my system. If I know the server and the port is open, since the port is open, I can afford to, right? There's a 23 open, there's a telnet service opened on this port with source, any. This is some of the things we need to look out for. Moving on, these are a simple diagram explanation of what happens if you have a firewall in your Azure environment. In Azure, there's something we call hub and spoke. So hub is like a central point. You have your firewall such that all traffic's coming to any of your servers within the spoke. If you force tunnel it, it will go through the hub for inspection. But what happens here is that institutions fail to configure the firewall. They just put the firewall there, we've put the firewall, but there's no filtering. So traffic is just, as it's coming from either VPN or express routes, or if it's Oracle Cloud, Fast Connect, it just goes through the hub and then moves to the energy. So the energy is just the one protected, right? But if you have double layer, like we always speak about, defense layer index, right? You have inspection at the hub, you have inspection at the spoke before it hits the server. It's always a good thing, right? So public bucket access, very important. I spoke about it. If you look at some of the exploits you've seen, it's always public bucket access. So there's Work Composer. So Work Composer is like an employee monitoring app, right? So what happened is they take screenshots of your images at points in time, and store, right? But what happened is they were stored in an S3 bucket that was left public, right? That was exposed publicly, right? With a simple URL, you can afford to see some of these stuff that been stored in the S3 buckets. And I did one, I'm going to share the HTTP link for it so we can access. When I go into the demonstration part, I'll drop the link on the chat so we can access just a simple HTTPS URL of the object, and you're able to see everything. So this is a screenshot of what the permission looks like. Block public access is set off. Everyone public access, everyone can list, everyone can read. It's always nice to manage your storage from the bucket point. That's the container. The objects are like the content of the container. So it's always nice to manage it from the bucket access control list points. Because of time, because I'm still going to demonstrate some things. Non-rotation of access keys and impact if stolen. This is very, very important. Now, in AWS environment, you have access keys that can lead to programmatic access. Someone wants to access via CLI. You can use your access keys, right, to actually authenticate. All right. So what happens is, in the past, you see that from engagement, access keys are not being rotated. So you go to an institution, they give you a global reader right to get into their environment. You're going to the access keys and you're seeing that the access keys have not been rotated in over 400 days. And you're wondering, and the person that was using that account has exited the establishment. And the person who exited had an administrator access. This exposes the institution, right? So it now becomes important. We should rotate access keys. As a matter of fact, AWS put out a publication. If you're reading their security best practice, they always advised against it. Use IAM rules, right? Now, but in cases, because you understand that there are always going to be exceptions. There are times that IAM rules might not really work. In cases you need to use these access keys that gives you long-term access to resource, rotate. If you're using it in place of like a service account that needs to make requests to so service, don't hard code it, right? Store it in AWS Secret Manager such that on your code there is a call that is made to the Secret Manager to obtain the key and use it to access that resource, right? So while we are reading the AWS security best practices, there are always there's that balance view. In the event that this is going to happen, if it's for a normal user, try to rotate. So consistent monitoring is important. And that was what happened to Uber. Sorry. So for Uber, there was, they were able to access their private source code repository using credentials that had been reused, exposed. They found an AWS access key there, and they used it to copy data from Uber's S3 environment, right? And they did that. So I'm going to show us how easy it is to display or to log on to an organization's AWS environment if the access keys are stolen. Please, this is purely for learning purpose. So I'm going to stop sharing and share my screen again. So let me know when you can see my screen.
All right. No, so please, we'll need to speed up things because we want some time for questions, right?
Okay, no problem. So I'm going to be sharing my entire screen. Please let me know where you can see my entire screen. Can you see my entire screen?
Yes.
Okay. So before I do this, I dropped a link on the chat, right? You can access that, and that's how simple it is. It takes you to storage of an organization. So this is a simple command line interface on my system. Now, what I've done is I was able to install AWS CLI version 2 on my system, which you can see. So if you do AWS-V, you're able to see that I have AWS-CLI installed on my system. Now, I'm able to AWS configure, right? Now it's going to ask me for an access key, right? So I have my access key here. I'm going to paste that, enter. Secret access key. I'm going to paste that here, enter. Default region name, enter, right? Now this is what you have. As simple as that. I am in my test AWS tenancy, right? So if I want to know the user I am logged in as, I can do a simple STS get caller identity, right? And when I run that, it tells me who I am logged in as, right? Hold on, be a black. Okay, as you can see, this is it. This is the user ID, this is the account, and this is who I am logged in as, Jennifer, right? So an attacker can say, oh, okay, I'm logged in as Jennifer. What does Jennifer have, right? So I can do a simple AWS I am, right? List. I want to list user, or let me say list attached user policies for Jennifer, right? Let me see what role or what Jennifer has, right? So you can see attached policy, she has an administrator access and she's yet to change the password upon the next logon. Okay, fine. So Jennifer has an administrator access. What can I do? I can afford to list out. Let me list out all the buckets that currently exist within this AWS tenancy. And this is it. You have everything, all the S3 buckets that exist. Okay, I'm seeing also production too, and I want to understand what is actually in this also production too, right? So I can afford to list. Let me list what exists in also production too, right? You have encrypted file or TXT, and you have password.txt. So these are the buckets, and these are the objects in the buckets. I can say, okay, fine. Let me download this stuff, right? Let me put this on my system, right? I can afford to AWS S3, copy them, right? So I want to copy the entire bucket into my local folder. Let me put it on my desktop, right? Let me copy the path. Let me put it on my desktop. I can do this. I can come here. I can clear this. Now, because it is a bucket, right, and there are objects in it, I want to copy everything, both the buckets and the objects, right? Everything, all the content of this bucket, so recursive, right, to be able to do that. So when I do this, It'll take a bit of a while. Connection is unstable. Please permit my internet. Correct. So you see it's been downloaded, right? So if I go to my desktop where I was before, you can see the files there, right? So because Jennifer has administrator access, I can say, oh, fine. I can afford to copy stuff from the buckets down to my, as simple as that, right? Which hinges on the need to always rotate your keys and watch the permission you give, right? If I want to see the users that actually exist, I can just further do an AWS IAM list users, and it will show me it's showing me all the users. So you see the antivirus service accounts we spoke to, you see the inventory accounts we spoke to, you see the Jennifer account, you see the Olabode account, and that's it. So please, this is just for learning purpose, and this is where I will be stopping the demonstration. So let me go back to share my screen and just wrap up on what we can do, to protect our environment. What we can do to protect our environment.
2 minutes now, so.
How can we mitigate? Oh, sorry. How can we mitigate this misconfiguration? I'm just going to wrap through, right? Governance. You need governance governance is like the bedrock. You need security policies, you need hardening standards, you need cloud strategy, you need up-to-date network diagram that shows how you've segmented your VPCs or your VNets. Your test VLAN should not be able to hop into your production VLAN. That is key to avoid lateral movement, right? So it's not just your network diagram. Also test that to see, continuously learn and adapt. I'm still learning. Cloud is evolving. All right. What we can do for ourselves is to read white paper, security advisories, best practice guides, leverage native CSP tools. So if you're starting off, not to be scared. In Azure, you have Azure Advisor, Microsoft Defender for Cloud. In AWS, you have Trusted Advisor, Security Hub. In Oracle Cloud, you have Cloud Guard, right? And these are the things that can help you. It shows you your security posture at the point in time with the best practices. You have adopt independent cloud security posture solutions, things like Prisma Cloud, Oka Security or Checkpoint Cloud Guard. I know I have had interactions with Prisma Cloud, so I know how it works. It tells you the vulnerabilities that exist within your cloud environment. So because of time, these are some of the things that we're going to speak more or dwell more in the IT bootcamp session. We're going to drill deep into it. So at this point, right, I'd like to end here and also say that security is something that we should take serious, right? What we have on-prem, let's try and replicate similar to what we have in our cloud environment, because these little mistakes can actually put us out there for the big risk. Thank you very much. Thank you.
All right. Thank you. Thank you, Nonso. You know how time flies when we're having fun, right? I don't know if we have any questions. I don't see any in the chat. I don't see any in the chat. Okay, if you want to ask your questions, you can just indicate by raising a hand so it can be answered, except we're saying everything is fine. I know it's a lot to take in. Part of what we'll do is that the video will be shared on the community YouTube page. We will also be sharing the slides just in case there's anybody who needs to use that as a resource. Yeah. So any questions? Contributions? Okay. If there is none, let's me end by, just in case there's someone who is joining this our session for the first time, this is the Tech Assurance community. We are a community of tech risk managers supporting each other grow our careers. And we're able to achieve this through some of these knowledge sharing sessions that one of which you are in attendance. We also share a lot of resources required to aid our effectiveness on the job. We offer mentorship. We provide platform for professionals to express themselves. Again, the community also serves as a talent pool for folks who are looking to hire quality tech and cybersecurity resources. We are driven by our mantra that we rise by lifting others. So if this is a community you'd like to be part of, you can do so using the link in the chat. I'll just drop that in a bit. You would also find, I'll also be dropping past resources from the YouTube page. If you think that will, I'm positive that you would find that useful as well. I see a question from, is it Trisha? Trisha, do you want to ask your question? Please go ahead as we wrap up.
Hello, good morning, Tony. My name is Mohammed.
Good morning, Mohammed. Hi, glad you could join us.
Yeah, thank you very much for this insightful session. So, my question and also suggestion is that I work with a bank, and also just 3 days ago, a bank I know was hit over 2 billion naira. So, and from the findings, it was the CISO and some of the top security officials lack um, lack a certain knowledge to ensure that environments such as our cloud and our on-prem environments are kept secured from unauthorized access and breaches. So, in a situation whereby that knowledge is lacked, how do we ensure that we as staffs, as team members, escalate to management to ensure that people who man such positions have those requisite knowledge to ensure that our environment are kept safe, protected from such attacks? Thank you.
Hey. So we can't really overemphasize the need for us to learn, unlearn, and relearn. And if you check, it's part of the reason why some of us may have joined this session. Technology is constantly evolving, and so yesterday's knowledge may not necessarily take you into tomorrow, right? And that's why you want to be on top of stuff. I'll tell you that it's part of what excites me about the job that I do. I don't love monotony, so, but because it's constantly evolving, you have to be on your toes, or you have to keep learning. Now, one thing that we don't do too well from the tech side is that we don't, let me say, technology managers, either we rely a lot on residual knowledge, or we deliberately do not try to expose ourselves to new information. Sometimes we're waiting for the institution to train us. That in itself may have its own challenges. Somebody tells you he doesn't have a budget or whatever, and then the staff himself is saying, well, if you don't train me, that's your problem. And so again, in summary, I'm just saying sometimes it might just be an institutional issue. You don't have a budget for training, so you need to create one and be deliberate about specific domains where you want your staff to build capacity. But let's not just leave it for the institutions themselves. We should be deliberate in building capacity, right? When we started, in my introduction, I had said that Nonso is a chartered accountant, today he's a cloud security engineer. I'm sure that some of us will be wondering, chartered accountant, cloud security, from where to where? How is that even possible, right? But there's really nothing you can achieve if you put your heart to it, right? So I don't know if that helps.
Thanks very much. Thank you.
Patricia says, can we have a record after the session? And also, if there's any question, we can have a question in the chat box after the session. Yeah. Sure. The recording will be made available. Okay. I think our task is done. We are 1 minute after 11. I had promised that we will not exceed that time. So let me wish us all a fantastic weekend and see you next month. Bye, everyone.